Welcome to Uma's Classroom for Math and Science videos. This video is on the topic Law of Reciprocal Proportion, that is a part of Laws of Chemical Combination from High School Chemistry and AP Chemistry curriculum. There are certain rules followed by all atoms while combining to form a compound. Those rules are collectively known as laws of chemical combinations. The first one of these laws of chemical combinations is the law of conservation of mass. The second one is law of constant composition or law of definite proportion. The third one is law of multiple proportion. We already have discussed all these three laws in three different videos. This video is on the topic law of reciprocal proportion. Law of reciprocal proportion was first proposed by Jeremiah Richter in 1792. It states that if two different elements combine separately with the same mass of a third element, the ratio of the masses in which they do so are either the same or a simple multiple or submultiple of the mass ratio in which they combine. This law is also known as the law of equivalent proportion or the law of permanent ratios. Along with the law of definite and multiple proportions, it is one of the fundamental laws of stoichiometry. If element A combines with element B and also with C, that means when A is combining with B, it forms AB, and at the same time A combining with C, it forms AC. Now, when B and C combine together, so when B and C combine together, they are forming a new compound BC. The proportion by mass in which they do so will simply be related to the masses of B and C, which separately combine with a constant mass of A. Let's look at these three compounds. Here the constant mass of A is this one. Here the constant mass of A is this one. So with this constant mass of A, when B and C, they are combining separately, their mass ratios are as B is to C. Now let's look at this compound BC. Here also we can clearly find out the mass ratios of B and C is again equals to BC. This is the mass ratio. And the law is also stating that this mass ratio should exactly be equal to this or maybe a multiple or submultiple. In this case, these two ratios, this one and this one, these two ratios are exactly same. The existence of isotopes of the element causes some discrepancies to the law of reciprocal proportion. Let's take few examples for law of reciprocal proportions. Example 1. Suppose the compound we have taken, it is copper sulfide. So in copper sulfide, 63.5 gram of copper is combining with 32 gram of sulfur. And the second compound is copper oxide, where 63.5 gram of copper is combining with 16 gram of oxygen. Let's look at the mass of copper over here. It is same for both the compounds. Next, we have to check the ratio of the masses of the other two elements. For these two compounds, the other two elements are sulfur and oxygen. So let's check their ratio of masses. Here it is 32 coming from here, and here it is 16 coming from this compound. And the ratio, upon simplification, it is coming 2:1. According to the law of reciprocal proportion, when sulfur and oxygen, they will combine to form some new compounds, maybe sulfur dioxide, maybe sulfur trioxide. Either they will do so following the same mass ratio of sulfur is to oxygen, or it can be a multiple or submultiple. Let's check. For sulfur dioxide, the mass ratio is 32:32. That means 1:1. For sulfur trioxide, it is 32:48. Means it is 2:3. Now let's compare these two ratios with the standard one. If we look at this mass ratio, it's clearly seen that the part of the ratio is the submultiple of this standard one. Whereas if we look at the mass ratios of sulfur trioxide, here also it is clearly seen a part of this mass ratio is a multiple of the standard mass ratio. That means the law of reciprocal proportions holds good over here. We can consider another example where the compounds are pH3, that is phosphine, and the second one is PCl3, that is phosphorus trichloride. So for this first compound, let's get the mass ratio of phosphorus and hydrogen first, and it is coming 31:3. Whereas for the second compound PCl3, the mass ratio in between phosphorus and hydrogen is, here it is chlorine. So the mass ratio of phosphorus and chlorine in PCl3 is going to be 31:35.5 times 3, which equals to 31:106.5. Let's look at the mass ratio of hydrogen and chlorine, that is combining with a fixed mass of phosphorus, that is 31 over here. And from this calculation, this mass ratio is coming as 3:106.5, which upon reduction gives us 1:35.5. Now, let's look at the mass ratio of these two elements, hydrogen and chlorine, when they are combining themselves to form the new compound hydrogen chloride. And here we can clearly see the mass ratio is coming as 1:35.5, which is exactly equal to the expected mass ratio. So we can definitely conclude that these example is in good agreement with law of reciprocal proportion. Here we can see another example where all the masses and combining elements are shown in the form of a table. Our first compound is CH4 methane, whereas the second compound is carbon dioxide. So in this triangle, here is methane, first compound, and here is carbon dioxide, the second compound. And combining element for the first compound, this is first compound. For the first one, combining elements are carbon and hydrogen, whereas for the second compound, this is second compound, the combining elements are carbon and oxygen. Now, combining masses for carbon and hydrogen for this example, that is methane, is 12 and 4 respectively. So this gives us the impression of carbon and hydrogen mass ratio, which is going to be 12:4. Upon reduction, it becomes 3:1. And now if we check the mass ratio for carbon and oxygen from this compound, it is coming 12:32. Here is also a chance of reduction, and upon reduction it is coming 3:8. Now let's look at these two mass ratios. Here the mass of carbon is fixed in these two compounds. So the mass ratios of hydrogen and oxygen that can separately combine with a fixed mass of carbon is going to be 1:8 from this calculation. Now, when hydrogen and oxygen, they are combining together to form this third compound. Now, let's look at the mass ratio of hydrogen and oxygen. From here, it is clearly seen the mass ratio is coming 2:16, which upon reduction comes as 1:8. And if we look at the standard ratio, this mass ratio of hydrogen and oxygen in water is exactly equal to the standard ratio. So these examples are also in good agreement with law of reciprocal proportions. Based on these calculations and the theory or the statement of law of reciprocal proportions, the numerical problems can be solved easily. Here I have one numerical problem. Illustrate the law of reciprocal proportions from the following data. KCl, this is our first compound over here, contains 52% of potassium. And Ki, this is our second compound, contains 23.6% of potassium. So first let's deal with these two compounds, then we will think of the third one. So here for the first compound KCl, and this is the second one, as the percentage of potassium is shown as 52 over here, let's find out the percentage of chlorine for this compound. And obviously it is going to be 100 minus 52%, that equals to 48%. Now from these two informations, 52% of potassium combines with 48% of chlorine. Therefore, 1% of potassium can combine with 48 over 52% of chlorine. Here actually the mass of potassium is not fixed. So we have to make it fixed in any way. And it becomes 0.92% of chlorine. Now let's perform the same type of operation for the second compound, and percentage of iodine for this compound is going to be 100 minus 23.6, which equals to 100 minus 23.6 equals to 76.4%. Here also we can see the mass of potassium needs to be adjusted with the fixed mass, which is 1% over here. So just like before, 23.6% of potassium combines with 76.4% of iodine. Therefore, 1% of potassium can combine with 76.4 divided by 26.3% of iodine. Let's finish this calculation. 76.4 divided by 23.6, it comes as 3.23% of iodine. Now, according to the law of reciprocal proportion, let's find out the mass ratio of iodine and chlorine when they are combining to form the third compound, which is ICl over here. And from our calculations, it is going to be, for iodine it is 3.23 is to, for chlorine it is 0.92. And if we reduce these values, it is coming as 3.32 divided by 0.92, giving us a reduced value of 3.5:1. Our third compound is ICl, which contains 78.2% of iodine. So 78.2% iodine. Therefore, chlorine equals 100 minus 78.2, which equals to 21.8%. Now, let's check the mass ratio of iodine and chlorine from these informations. It is coming as 78.2 is to 21.8. Let's do the reduction part. 78.2 divided by 21.8, it is coming 3.5:1, which is exactly equal to the expected ratio. So we can conclude the law of reciprocal proportion is strictly followed for these examples. This is all about for our today's discussion. Keep watching math and science videos from Uma's Classroom. Keep growing with Uma's Classroom.